Hello, future chemist! This is AH
and SH here to teach you about
significant figures. Now, you can probably tell from its name that the concept is pretty significant to master.
Let's begin with a quick discussion of why we use significant figures in chemistry.
Not everything in the world is perfect measurement. Data collected is not always precise, so scientists use significant figures so that measured numbers do not appear to be more accurate than the equipment used allows.
To give an example, it is improbable that someone could measure out exactly 12.345678 milliliters from a 25 milliliter graduated cylinder. Thus, significant figures allow scientists to calculate data even if they are uncertain of the precise number. We use significant figures in measured out data from experiments, such as weighted masses or calculated temperatures. To illustrate, a common balance may calculate to the 100th decimal place. If a watermelon weighed 6.35 kilograms, then you would use 3 significant figures in the problem.
However, if there are multiple values with significant figures, you must remember to always use the least significant one. This is important in solving chemistry problems. Exact or known numbers, such as 12 inches in a foot, do not have significant figures, as they are not ambiguous.
All measured values are significant. There are a couple of rules to follow when determining how significant a number is. First, all non-zero numbers are significant. To exemplify, 12 has 2 non-zero numbers, so it has 2 significant figures.
Moreover, zeros between a number are also significant. For example, the zeros between 1002 would be significant, as they are bounded by 1 on the left and the 2 on the right.
Decimals also play a key role in determining the number of significant figures. After a decimal, each number, including zeros, are significant. The zero before a decimal number, however, is not significant. To illustrate, 0.01 has 2 significant figures because of the 0 and the 1 after the decimal, but not the 0 before.
Zeros that are after a number but are not bounded by a decimal are not significant. 100, therefore, would have 1 significant figure since there is no decimal present.
We can also use scientific notation to restrict ambiguity in the number of significant figures. For example, we can go from 15,000 to 1.50 times 10 to the 4th to use 3 significant figures instead of 2.
And now, some examples!
First, take a look at these 2 numbers. The first number does not have a decimal, but the second one does. Because the first number does not have a decimal, the 0 is not significant. Therefore, it only has 1 significant figure. However, the second one does, meaning that there are 2 significant figures in the number. Next, take a look at these 2 numbers. The second one has a 0 at the end, meaning that it would have 1 more significant figure. Therefore, the first number only has 4 significant figures, while the second one has 5. Now, take a look at this number. All of the numbers have significant values. Therefore, the number has 13 significant figures because of the numbers left and right of the decimal. Next, take a look at this number in scientific notation. Since it is in scientific notation, only the 1.0 is significant. Therefore, this number has 2 significant figures.
Now that we saw how significant these figures are,
let's make that chem grade more significant. See you next time, chem grads!